Okay. Ladies and gentlemen, dear Dr. Abiteboul, dear Dr. Flandrin, esteemed colleagues, dear students, honored guests, and also dear everybody who is following from home this very interesting night and debate about the challenges and the opportunities of artificial intelligence. This is the third session of the conference series on major challenges for the future that we co-organize with the French Academy of Science. So today, the topic is very interesting, as usual. It's very challenging, and we decided to invite two researchers that actually had a huge impact on the world of today's, on the technology of today's. And believe it or not, every time we go on a website, maybe, or we use a piece of technology, we're actually using and leveraging some of their research, whether it's a database, whether it's a signal processing. And more importantly, both of them, they engaged into a more ethical use of technology and a more open use of technology. And that's why we decided to take their point of view on this very critical matter. Artificial intelligence is something that changes every day and is disrupting many industries. Probably one of the first industry sector that got disrupted by this revolution is our sector, the sector of education. 1.5 years ago, when the first waves of Gen AI became higher and higher, and most of the people in this class and at home started to using ChatGPT, most of the students were starting to using to get their essay done. The big question was, what do we do? And after a few weeks of reflection, we decided that we had to embrace this change. We had to embrace this technology. So we studied a lot. And then a few months ago, we signed a partnership with OpenAI. We are the first business school in Europe to have signed a partnership with them. We're working with them, of course, because we want to equip our students with the use of this technology. But on the other hand, it's because we understood that the only way that our students can master the technology and not being mastered by the technology is if we use it every day, if ourselves are at the heart of this change, if institutions like us drive and influence the industry sector, not only from a technological point of view, but most importantly in the usage and the ethical usage of this technology. For this reason, tonight, we have this interesting debate, and we want to pick from the experience of Serge Abiteboul and Patrick Flandrin, which they will for sure provide us with a lot of answer, maybe, but many questions that in the next coming year will need to be answered by all the society at large. So, in closing this opening, I thank again the Academy of Science, the French Academy of Science, for their support in this series of conferencing. And I call on stage Clément, who is at the head of a very important association at ESCP, and who will be introducing in detail the background, the CV, and the experience of our two esteemed guests of tonight. Thank you so much.
I would like to thank Mr. Arcellino for his speech, and I will now present our two guest speakers this evening. Mr. Serge Abiteboul and Mr. Patrick Flandrin. Well, Mr. Serge Abiteboul is a French computer scientist specializing in data management, database theory, and fleet model theory. He was born on August 25, 1953 in Paris, and studied at Telecom Paris before receiving his PhD from University of Southern California in 1982. He also graduated from the Université Paris Sud with a state doctorate, and at the French National Institute for Research in Computer Science, an automation also called Inria in French. Abiteboul has been a senior researcher and has made significant contributions to database systems and finite model theory. For his achievements, he was awarded the ACM Sigmund Innovation Award in 1998 and inducted to the French Academy of Sciences in 2008. In addition to his academic pursuits, Abiteboul has been in significant positions such as the French National Digital Council and at the Electronic Communication and Postal Regulatory Authority. He's also a novelist and has actually been the author of a blog called Binaire on Le Monde, where he posts articles on about computer science and digital technology. Mr. Patrick Flandrin is a renowned French physicist. He graduated from his part from the Institute of Industrial Chemistry and Physics in Lyon, and now called CPI Lyon, in 1978, and obtained his doctor engineer degree in 1982 and doctorat d'état des sciences physiques in 1987 from the Institut National Polytechnique de Grenoble, so all in the south of France. Flandrin joined the French National Center for Scientific Research, CNRS, in 1982 and has since emerged as a renowned authority on signal processing with a focused theory on time frequency analysis. He established at the École Normale Supérieure de Lyon the Signal System and Physics Group in order to integrate many fields of study. He has received several honors for his work, including in 2010 CNRS Silver Medal and a mission to the esteemed French Academy of Sciences. He also held some prestigious positions, such as the one of President of the Academy from 2021 to 2022, and Vice President from 2019 to 2020. In addition, he's the author of publications like Explorations in Time Frequency Analysis and Time Frequency Timescale Analysis, quite a long name, sorry, which are now required reading for everyone interested in signal processing. So I would now like to call on stage Mr. Patrick Flandrin and Mr. Serge Abiteboul to present their quite impressive works to us this evening. Thank you very much.
Thank you. We need the computer. We have some slides. Thank you. Do I need to speak in the mic? Yes. Works. Thank you for the invitation. So we're going to speak about artificial intelligence and try to get across a couple of ideas. So first of all, what are we talking about? So if we look at fiction and folklore, everybody knows what AI is. It's a long story with very famous books and movies now. And then something changed in the 20th century. It's the arrival of computer science. And actually, interestingly, computer science and AI were born about the same time with scientists like Turing, for instance. And we all understand what computer science is all about. And the idea is to ask a machine to perform some actions. And when you ask the machine to perform some action, this is basically artificial intelligence. So that's why the distinction between computer science and AI is very difficult to make. So AI, strictly speaking, if you ask me what it is as a scientific topic, I have no idea. Okay? And that's very embarrassing because I've done AI research my entire life. But I cannot really define it. So I think this definition from the AI Act, from the European community is pretty good, but you see it's kind of long and it's not very scientific. What's very important, and that's why we're probably here, is that suddenly AI brought some very, very fantastic results. So this was around 2000, and then it really became known in the 2020s by the general public with ChatGPT and so on. So you have to understand that it's a long story of AI that dates from the middle of the 20th century, and there have been very important results all along, but really the technology that most of the time we're talking about is very specific part of AI, which is machine learning. So machine learning, and for if you speak French, there are two very good lectures at Collège de France, one by Yann Lequin and the other one by Benoît Sagot, that I strongly encourage you to listen to. And the idea of machine learning is extremely simple. When you don't know how to describe precisely a mechanism to the machine, you'd like some action to the machine by a machine. But if you don't know exactly what algorithm to ask them to do, you're in deep trouble, because basically, you know, what am I going to ask to do? Okay, I don't even know how to explain it. You know, or recognize a cat from a dog. Baby can do that, but how do you explain to a machine how to do it? You know, tell them, you know, look at the tail first. So what do? You have absolutely no idea. So in that case, what you do is you say, well, you know, learn from examples or learn from trying, okay? And that's what machine learning is all about. Some algorithms, typically neural networks, that have been developed. It's heavy technology, and really, it's building on of three things. You know, suddenly it appeared that in the 20s, at the beginning of this century, it started working. Why? Because people have been working on that since the very beginning of computer science, and they've tried it in the very beginning of computer science. But suddenly, all the planets were there. And this is a triangle. First of all, we got to a power of computers that was really what was necessary. So before that, we wanted to do things, but the computers were too slow. And suddenly, we had these huge computers that were computing so fast. Second thing is, we needed data. You say, you know, try from data. Well, okay, where is the data? And there was data, but it was not sufficient. Now we have huge corpus of data. In particular, for the most typical problem was understanding the language, understanding how you speak English, understanding how you speak French, Chinese. You need lots of examples to teach a machine, and that's now becoming available. And also great new algorithms that were developed, in particular by Google, often also by research labs. Okay, but all that is about machine learning. That's the thing that you see most now, and for good reason. That was blocking us, and suddenly it's solved. Okay, but you have to go one step back and look at AI from the very beginning. And typically, there have been two branches of AI. One was symbolic AI, with reasoning, proof, automatic proofs. We're talking about databases. My topic. This was all about symbolic AI. And then there was like this neural AI or statistical AI or machine learning, which essentially had very limited results for many years, and they have big results now, okay? That's, in a way, a separation in your mind. But if you really look at what's coming up in the future, it's basically a mixture of both. And I'll just illustrate it by one example. And essentially, this is the kind of things that's going to fix most of the problem that you see now with machine learning. This example is about alpha geometry of Google DeepMind. The problem they did was how about solving geometric problems. And they took the geometric problem from the International Mathematical Olympiad since 2002. So these are very specific problems. So they gave that to one of these generative AI systems, ChatGPT, whatever. Zero result, just doesn't work. They couldn't solve a single problem, okay? But then they said, how are we going to do that? And basically, they merge this generative AI with a symbolic theorem prover, okay? Which means what? basically the generative AI, the way you work with ChatGPT, comes up with a possibility of an answer. I've seen, you know, like many answers of geometric problem, many solutions of geometric problems. Very often they look the same. You know, I'm going to take an extra point, I'm going to do this and that, and oh, great, I have the result. So they dream, the generative AI dreams a solution and writes it. And maybe it's a solution, most likely it's an hallucination, okay? So the theorem prover comes behind and work and say, no, that's not a proof, that's garbage, because that's wrong. And the generative AI tries something else and tries something else. By doing that, they solved 25 of the 30 geometry problems of the Olympiads. So that's a fantastic result, because that's the problems that we're going to solve in the future. We need, at the same time, something that gets ideas, can generate things, and that sometimes doesn't tell you trash. Okay, so those are the limitations. I'm going to go pretty fast on that, even though it's a little bit the topic of this of the talk. Patrick will come back in more details, but basically, if you have tried ChatGPT, you've come about all these problems, the bias, lack of explanation, and so on. Now, one step aside, okay, these are the problems today. It's not the problem of the computer science technology, it's the problems of machine learning today. And if you discuss with the people in the labs, in the research lab of Inria, in the research labs of Google or Facebook, Meta, sorry, they all tell you that they're fixing them. Now, if you ask researchers, they tell you they'll fix them next year, okay? I'm becoming a bit more, you know, skeptical. They're going to be fixed, but it may take time. I don't know how long, but they're going to fix it. Okay. And the example that I gave you of DeepMind with geometry is a good example of fixing the problem. You know, the generative AI was dreaming of some proof of a theorem, was wrong, but now, together with some symbolic theorem proving, it works. Now the benefits, name it. Okay, you know, it's possible to see some fields where you don't have AI benefits. Hairdressers, not yet. But you know, 10 years ago, I would probably have, I would not. I think I was using taxi as an example. And now it's very embarrassing because AI, of course, has completely transformed the business of taxi and probably may just cancel this profession in the future. But you know, I don't want to take one in particular, but you can just read it down. AlphaFold got a Nobel Prize in chemistry. So these are really game changer. It's not just something that's, you know, it's not some gadget that's changing on the margin. They're really changing fundamentally, for instance, research, and research in all areas, pretty much. Not only actually scientific, hard science, like, of course, physics, of course, chemistry, but also in humanities. Okay, once you say that, we should not forget about the limitations. You know, basically, people come and say, we're going to change the world. Okay, we want to be careful, tell us. And I'm going to focus on two aspects. And again, Patrick will go into more details about all these aspects. But I want to mention two. One of them is the fact that people are disappointed often. You hear that a lot. You know, they came and they say, well, I have this problem, this is my problem. In education, for instance, I was working with the foundations, and they say, well, we could use AI. And then they tried, and it didn't work. It didn't work today. And why didn't it work today? Because the problem was very complex, and the solution was not immediate. So sometimes startups, research labs have a tendency to say, well, we're going to solve that immediately. No, it's just complicated. I want to take an example, the Compass system that you may have heard. It's a system that's used in the US to help the judges decide on parole, and they gave that to judges, and then there was like big argument whether this software was racist or not. And some people showed that actually the software was giving a less probability of freedom for a person of a minority, minor ethnic background. And some people proved the opposite. They proved that, no, indeed, it's not true. We've proved that that's the software is not at all racist. So first lesson, it's not very easy to define whether a software is racist or not, because these are difficult issues. So complexity of the problem is something that has to be taken in consideration. But the main point I wanted to make there is at some point they decided to ask judges what they thought about the software. And they say it's trash, the results are bad. So it was just a bad software, okay? Because the problem was very complicated. And something that you have to keep in mind, you can have bad software. And now the other point is, that's something that really surprised me. At some point, you put ChatGPT on the desk of everybody, and everybody's totally impressed. And now, when I say everybody, I mean including people who have, like me, who have worked on the topic and have seen that in labs before and so on. But still, when I use ChatGPT, I sometimes even have the temptation to be, oh, it cannot be possible that it's so good. It's impressively good. How can that be? So I repeat, there is no magic in it, and I'm trying to explain a couple of things, to find some couple of reasons. One of them is that we don't really understand human beings, and that's, it's learning from the language of human beings, so we don't understand how it works. And the second thing is, we are used to be impressed by hearing some people we're meeting in a cafe or in a restaurant or for dinner. Maybe they're just repeating. Okay? So I remember being very impressed by somebody for dinner saying something very, very smart, and then it was a long time ago, I realized, and the old people will recognize that, I realized that the person was just quoting Lagarde and Michard. So maybe the same thing that happens here. And tomorrow, so I'll go fast, we have known that we are not the center of the world. With AI, we know that we have not the exclusivity of intelligence. And of course, this brings us to the question that we're discussing before this talk, is what makes human beings different, okay? And I'm insisting on different, not superior, different. Why are we different? And creativity is put forward, feeling is put forward, freedom to choose is put forward. It's very difficult because one after the other we break it, okay? Or we show that it's not so clear, it's not so obvious. But I think it probably doesn't make a difference to know whether we're different because of this or that. What's very important is that it's making us think about what it means to be a human. Personal opinion, there is no limit, okay? If a task can be performed, if a task can be performed by a human being, I see no scientific reason why it shouldn't be able, a computer, an artificial intelligence, a software, whatever you want to call it, won't be able to do it in the future. I don't have a proof of that, and you'll find scientists who believe exactly the opposite, but that's my personal belief. And now, of course, the only thing I can do, it's a belief, it's not a proof, it's not a theory, but I can give you some hint about why I think that, is because in the past, I've already some gray hair, white hair, I've heard so many people telling me, computers will never be able to do this. And they were always wrong. There's not a single case where they were correct, okay? When they were capable of articulating something very precise. Okay, of course, if they tell me, computers will never have soul, I don't know. I cannot tell you because no definition. But if you tell me a task, a precise task, always show to be wrong. Warning, the fact that a machine can perform a particular task doesn't mean we want to give it to it. Okay? If we do a machine that's better than a judge tomorrow, I think we can decide as a society that we want human judges. Maybe we don't want human judges, but that's something that we'll have to decide. And the idea that because a machine can do it doesn't mean that we have to do it. Conclusion, education and training, that's the only thing that we can do to face these changes, as I said, that are fundamentally changing the game. And changing the game everywhere, in science, in business, in humanities. Education, education, education. And now there are some more societal issues. One I like is if machines are doing all the work, okay, suppose that sometimes machines will be able to do all the work. What are we going to do? What are we going to do of our spare time? Okay? And also, how are we going to live? I mean, if the machines get all the money for the work and we don't get everything, we die. And a society where 80% of the people won't have work is a society that just cannot function. And also, what are we going to do with them? And that's very important for education also. How do we live with this machine? What kind of task do we give them? What kind of tasks we don't want to give them? And there are also environmental issues that are fundamental because we cannot ignore that today, but I won't talk about it. And I conclude with an advertisement for, if you're interested in AI, by a play that I wrote with some friends, and that's showing till December 31st in Paris. And I left flyers if you're interested. And now, Patrick, your turn.
You switch to my. Thank you very much. Serge has said a lot of things, so I will not repeat most of the things. The general picture he gave wonderfully. I would like just to make some comments about some of the achievements of the bottlenecks, which are related to AI and to this kind of new techniques. First, in terms of achievement, there is this graph, which is one measure of what we can expect or not from artificial intelligence in terms of performance. So this is something which is a measure of, I think I have a pointer, yes, of whether some AI systems do perform better or not as compared to humans. And we have a 0 level which is here, which is supposed to be measuring the human performance for a given task. And this graph means that if you are above, it means that the AI system perform better than humans. And if you are below, then, of course, the converse is true, and that the humans were better than AI. And when we see this graph in terms of progression over the years, is that for a while, of course, performance of the AI system were not that good, but reasonably evolving and even fastly evolving in some cases. And at some point now, since we are here around 2020, then many tasks are performed better by these systems than by humans. So let's see more precisely what it means in terms of with different examples. First, historically, there has been some good success for handwriting recognition. That was even with the system developed by Yann Lequin at the very beginning of what will be the performance of the deep learning. But this was in the 80s, before we had really the capabilities of the computer resources. But nevertheless, for the check sorting, for instance, it was some task which was very important and which was successful. Then we have a lot of things related to language and reading, comprehension for text, but also understanding of language and translation, which is something which is very important. And I guess that many of you are using AI systems like DeepL, which are now extremely good for doing this task. Well, I would say that 10 years ago, something like this, people were always making jokes about systems who were translating in a very funny way things because they were not that good. I think that this is no more the case. And what is very interesting is that now, with this, we can really enter an era where we can think of multilingualism, which is one way, indeed, of sharing knowledge without necessarily being uniformized by using something which could be English, Globish, or things like this, because the power is in the way of going from one language to the other one. So there are a lot of problems, of course, because depending on what kind of language we have, we not necessarily have the same size for the corpus. For instance, for very rare languages, this is not like for English or Chinese, but nevertheless, there are a lot of improvement on this, and this is a very active domain where we have very significant achievements. Of course, we have a lot of results in, for instance, image recognition, and this is important in medicine for medical diagnosis. So this is something which comes from signal and image processing, which are the beginning. We're really basically relying on models, and models are still useful, of course, but the revolution has been to introduce in this domain as well learning techniques, and this is something which is really an aid, not a substitute, but an aid for doctors for medical diagnosis. We can think also of projects like to equip vehicles so as to go to some autonomy in the vehicle. Of course, there are a lot of issues. I will not discuss about that, but this is some kind of perspective. And besides all these aspects, for instance, we can mention, and Serge did before, that in fields of science, really, like chemistry, the recent Nobel Prize was awarded to AI pioneers with AlphaFold, and this was really a nice combination of not just using with brute force AI system, but using them in a way which we take advantage of both the knowledge of the problem, but also the power of the computing system, because it was also something which was unachievable by humans, except if we accept to wait for centuries, I would say. Okay, nevertheless, there are some bottlenecks I would like to mention very quickly indeed. And first thing is that, of course, one big problem is that all the systems are more or less black box systems, which means that we know the structure. We know that by having a lot of example, learning by example, we will achieve some good result. But can we first really explain what is going on? And more importantly, can we get some guarantees about the result we get? So this is a critical issue because, well, if we think of human systems, in many cases, this is not necessarily a problem because we do not always explain why a decision is taken. But nevertheless, there are cases, think of security systems, think of the vehicles I mentioned before, of the medical diagnosis, for which we want to have some guarantees. And we cannot be just satisfied by saying that we have a certain percentage, very high, of good result, but we cannot really say something about the situation where the system failed. And this is an active area of research. How is it possible to better control and explain what is going on and have guarantees about the performance? The second thing is that, of course, all these systems have a lot of impacts. And the impacts can be, for instance, energetic and environmental. This diagram is just an illustration of the evolution over the years of the need of resources for training some AI systems. And there is some kind of constant evolution and increasing in the use of these resources, and this is a problem for, of course, the development of that. Is it a good way to just think that the performance will be better because we have more data, more computing facilities, and more, in fact, more training examples, and so. And this is both for the training of the system and also for the use of the system, where you introduce things like a rebound effect, because even if the systems are more efficient, the more efficient they are, the more they are used. But if they are more used than the efficiency is controlled, then you get anyway something which is worse and worse in terms of energetic resources. And so one question on which people are working on is how can we accommodate all the development of this system with issues related to sustainability and also maybe frugality. Not when you have a new system, not starting from scratch again, but can we use what we know from other systems? Can we do things with less example? Serge has mentioned the fact that this kind of intelligence in terms of learning is far away from what humans are doing for very, very simple tasks. A task which is to discriminate between a cat and a dog, of course, is performed by a child much more efficiently with very few examples and with an energetic efficiency which is much better. Does not need some cloud and things like this with hundreds of different computers. Okay, and finally we have also another thing which I think is important, is that the current system are some form of intelligence and some form of learning. And this is essentially something which is some form of intellectual learning, I would say, which comes from what we have through a terminal, through a computer, so images, text, and things like this, but which is not directly related to the physical world. And now, if I take the other example of learning for children, if you want to learn what is gravity, what means that if I drop something, it will fall. If I want to learn something about a fire which is burning, of course, you will not need hundreds of trials to understand what is going on. And this is because you have a physicalization of the learning. And this is something which has been done, of course, in fields like robotics, but globally, most of the current learning is much more in terms of text, image, and audio, and a little bit outside of the real physical world, and not directly in the physical world. And this is, I think, an issue, which means that this is not a complete form of what we could call intelligence or comprehension. So, nevertheless, I would say some words about the revolution of generative AIs, because I think that for most people, including me in some sense, there has been something before, I would say, ChatGPT and after ChatGPT, because before, as Serge mentioned, AI was kind of sci-fi. It was, okay, science fiction. We could admit that maybe in some future, very, very impressive things will be done by machines, but we are still lacking some proof. And then with generative AIs, starting from ChatGPT for text, then DALL-E, Midjourney for images, Suno for audio, which is a very nice system which has just composed songs. So you prompt, okay, the text of the song you want to hear and the type of music you want, and you get something. Okay, and it's quite impressive. Then people started using this and realized that it was there. And of course, this was not without any problem, because we have to have some literacy about that and to understand in some way what is going on so as to use properly these new tools. So, are the production of this system really intelligent production? So this is a question we can ask. And of course, it depends on what you mean by intelligent. At least what we can say first is that when you are considering texts, for instance, for their production, their completion, the translation is very, very effective. I mentioned DeepL and all these systems. And this is really based on massive learning and some large language models. But the key point is that the output when you have some prompt in your system, the output is just a result which is among the maximally probable result given the input in function of the corpus on which you have based your learning. So you have a corpus which allow you to compute some kind of probabilistic model for the data, and then what you obtain, for instance, for completing, is something which is not always the same answer, but something which is related to a maximal probability of what is expected. Okay, so when, for instance, if you ask something which is related, I don't know, about a temperature in January or temperature August, of course, the result will be different, and this will be based, and it's unlikely that the system will tell you that August is a very cold month and January is a very hot month, but just because it has been learned by all the data in the corpus, which means that there is no question of truth. That's a question of probability. And this is something important because in some cases, we can have a misconception of what is the result of the system by considering that it will give you the good answer to your question. It will not necessarily give you the good answer or the truth. It would tell you something, give you something which is probable. And as soon as, for instance, very factual things are at stake, you just make the trial with most of the systems, you can obtain something which looks like an actual answer, but which can be completely false in terms, for instance, of dates of data, which are just ask the system to write your biography, and you will see that you will be surprised by things which are completely false, but they are not false in the sense that this is not the purpose of the system. The system has never said that the answer will be a correct answer. It just will be an answer which is probable given what you ask and what the system knows. And so you might have some biases given by the training corpus itself, although I would like to moderate this idea of bias because there are a lot of issues related to that. What is a bias? A bias is supposed to be something which is different with respect to a norm. And of course, this raises a number of questions of what is the norm, who has decided which is the norm, and so on and so forth. And this would be interested to have the debate. And also you have, the systems are supposed to be automatic, but they're not completely automatic. That of course, there are some human controls for controlling the acceptability of answers for legal reasons and also for ethical reasons or for just cultural reasons. And this generally is invisible and you have no idea that, but it is there, and this in some sense tends to give a format to the answer and to give some form of normalization precisely, which has to be questioned. And so from more legal point of view, because it's a probabilistic approach, generally there is no question of plagiarism. For instance, when ChatGPT writes for you an essay, it's unlikely that it will just copy-paste something which has already been written by somebody else. It will give you something which looks like. So it's not plagiarism, but nevertheless, this raises some legal and property issues because it depends on the corpus and where is the data coming from, okay? Is there any consent for using this data? And this is a very important problem. And when you consider the output, how is it used? And how can we accept it to be used? For instance, think of the deep fakes, which are just artificial creation, but we nevertheless have a lot of very, very, very important consequences for people who are concerned with this. And more generally, because of this idea of a probabilistic approach which is based on what is learned from corpuses which are given from most likely, let's just say, the Anglo-Saxon world, it gives you a certain vision of the world. And it tends to be some form, to give you some form of homogeneous and standardized vision of the world, which has to be considered. And if we go to creativity issues, that has been mentioned, because of the structure of this, in some sense, it's very efficient for tasks which are more tasks which are just copying. As Serge mentioned before, it's much more saying again or painting again or so, something which has already been done, maybe a little bit differently. Maybe you can make some style transfer. I don't think it's very interesting, but you can write some Monet painting in the style of Van Gogh, so what? Okay. But what about the disruption? And are these systems able to invent a new style, for instance, and not just reproduce something which is in the style of something else? Okay, I would not say that it will not be possible someday, but as for now, in the spirit of this probabilistic description where you give a solution which is a member of the same probabilistic framework, of course the disruption is not to be expected, because you are just, otherwise you will just get out of your system, which is a little bit the opposite of what is doing. And the other thing is that it corresponds to some kind of, because of the massification, to some form of drying off of the innovation. Because the more things you create which looks like what was in the corpus for the learning, when you input, when you use these outputs as input for the new learning for the next step, then you tend to increase, in some sense, the same. So the same will always reproduce the same. And so there is an open question, people are working on that. Is this going to some form of divergence of the system, or is this going to, by form of anthropic thermalization, to something which will be purely homogeneous and with no innovation? And I think this is one of the most critical things. Are these systems, if we were too optimistic by just using them and in every things, are there not, I would say, influence our own way of thinking about the world, so that we will think as the machines are supposed to think, even they are not really thinking, based on what they learn from what we did before. So this is one of my main reservations about this. Okay, I will stop here, and thank you.
Well, many thanks for both your speeches. It was quite interesting. And I think to kind of open this Q&A session, I'd like to come back to, I think the two of the main, two things that are quite important at ESCP, which is progress and sustainability. So you both talked about the sustainability issues in using AI. And actually, according to a recent report by the International Monetary Fund, regarding crypto mining and data centers, both of them actually data centers actually account for almost 1% today of carbon emissions. Knowing that AI is actually highly dependent on data centers, how could we actually answer this issue? And do you think this reliance on data centers today might prove an impediment to the development of AI tomorrow?
It's a very important question, but I think we should not consider AI in isolation. I mean, the real problem is the digital impact, the environmental impact of the digital world. Now, it is true that AI is for now is not a huge part of it, but is increasing very fast. And I'll take only one example for that, which is, and actually two, it's Microsoft and Google. Both were planning to reduce dramatically their carbon footprint. Microsoft was planning to go to zero carbon by, I think, 2030. And both said that they are basically canceling these plans because, in fact, this year they increased dramatically their consumption for generative AI. So it is becoming a serious problem. Now, the question is, and now back to the digital world, we have to reduce the impact of the footprint, environmental footprint of the digital world. We have to work on it. People are working on it very seriously. Now we start understanding, having all the measures. But now the question is not only to have the measures, is to take concrete measures to change the story. And we know what we have to do, but knowing what we have to do is not sufficient. We know what we have to do for airplanes, for the airplane industry. We know that we have to reduce dramatically the fuel consumption, and still we don't do it. Now, we know what we have to do for the digital companies. Whether we'll be able to do it or not, I have no idea. But we should reduce, of course. And there are technology for that.
I would say it's symptomatic to see that even if, for instance, companies like Microsoft have these plans of reducing, nevertheless, they need, of course, a lot of energy, and they are buying and restructuring the 3 Mile Island plant for a nuclear plant for their own energy, and they're not the only one. So this means, well, we can also think the other way, which can also think in terms of the users. And when we talk about literacy related to AI, it's also something which has to do of what do we really need. For instance, of course, you can impose people not to use the systems, but clearly. For instance, if you think of ChatGPT or things like this, we do not need necessarily to use ChatGPT every time for every question, every request, and so on. And so we can think about frugality in our own way of using these systems. But of course, this is something which has to be really not only, well, we can have an idea of what we should do, but that's not necessarily that we will do it. And so there is certainly things to do for on both sides. Well, thinking of new systems which will be more efficient in terms of using less resources. For instance, really at the beginning, for instance, for deep learning, it was well, some dozens of layers or something like this, and some thousands maybe of parameters, which seem to be huge. But now it's hundreds of layers and it's billions of parameters. And as for the data is of course exploding. And is it necessarily a good way to have more and more huge systems? This is a question we can ask. And can't we find a system which will be more efficient, exactly as we mentioned for the way a child is learning, with a much more efficient, with much more efficiency, considering the number of examples and also the consumption, the energy consumption.
And I just want to add that we have to also consider not only purely AI prime, but the digital world in general. Because if you look at the environmental impact, more than 70% comes from videos. And now that actually shows the difficulty, because videos, I mean, are we going to reduce videos? Are we going to look whether you're following a course of this university, or whether you're looking at a pornographic movie? I mean, this is the same technology. I mean, are we going to ask you to what are you doing with this video to limit your consumption? It's not very easy problem.
And also a very huge part of this comes from the terminals themselves and from the construction and for instance from the fact that we change how often do we change our smartphones? So now the turnover is less than 2 years, whereas we know that the system could be used for 6, 7, 8 years. But we are forced in some way by the global economic systems to change more and more often. And this has something to do with the rebound effect, because of course we have better systems which are more efficient. For instance, for the data centers. The data centers are now much more virtuous than they were in the past. This has been reduced by a factor of, I don't know, 10 or 15 or some percent, 10 times or 15 times in 15 years. But this has a tendency to make people using more the system. So the system is better, but you will say that instead of having something which is with, I don't know, 20 gigaoctet for your forfait. Oh, you say forfait? I don't know. For your smartphone, then you will have 80. So you are better in some way, but people are encouraging you to using more, and globally when you make the balance, it's not necessarily in favor of improving the efficiency.
To insist on what Patrick said, very important. Take out, from this talk, when you use your telephone, when you buy a telephone, smartphone, at the time you start it, you have used 70% of the carbon for this telephone. The usage is only 30%. The fabrication is 70%. So really, buy a reconditioned telephone.
I have another question. You talk about how AI can do many of the same things like humans do, and one of them is develop bias based on gender and ethnicity. So is it possible that we could build a program or technology that based on the observations of existing bias, but not to reproduce them anymore? Can we really make AI rather than more than the parrots?
We want to. I mean, the question is, we have a new technology. Do we want this technology to make our life better, or do we want this technology to make the problem worse? So for instance, we know that the systems are biased, and because typically the data is biased because you're imitating humans who are biased. So you want to make a system that is less biased. That's for sure. Now, we have technology to... So actually, we have to step back a little bit. What does it mean to make it less biased? You have data that's biased, but you want a result that's not biased. So what you're going to do is you're going to cheat the other way. You're going to unbias the other way. Now, it's great, it's very difficult, not because it's difficult to unbias, it's because it's difficult to define what you want. The real question is not a question of technology. It's not I'm a computer scientist. Most of the time, the question is not a computer science question. Most of the time, the difficulty is for you to express what you want. And that's not very easy. I'll take just an example, and then I'll give it to Patrick. In the American universities, they know that they have biases. And we know that they know that the American society is biased against some minorities. Now, then you want programs to make choices of students to unbias that. But to decide what you want to do has been a fight for 20 years. And computers are not going to solve the fight. The fight is a fight, it's a political fight. It's not a technical fight.
Yeah, I would like to come back a little bit to this idea of bias, because in some cases that the wording itself, which is a little bit misleading, because of course we would like to have systems which are better in terms of discriminations and things like this, which are not necessarily bias, because a bias is really something which is a difference with respect to a norm. This is the definition in statistics. For instance, you have an estimator of quantity, you know the truth, and then you get the result and you see whether this is biased or not, because on the average you will get something which will correspond to the truth or not. But in our social systems, it's a little bit more complicated, but because what is the norm? The norm is something which is also very cultural, and it depends on the cultures, and what we accept or what we impose is different. And for instance, okay, there are things we do not accept because there are problems which are related to murder and everything you can imagine. But more generally, of course, what could be considered as a bias in a given culture, Western culture, for instance, is not necessarily a bias in an Eastern culture. On the culture, and so when we do this, there is a political question. Who decides of this? And I think one of the issue is that this is not at all transparent, because as for now, who decides of what is acceptable or not in a system? That's the platforms. And that's not something coming from what, for instance, we accept as a democratic decision of the people and so on and so on. Why do we accept that on Facebook you can not publish things which that you can find in museums, for instance? Who decides this? It's not a political decision, it's Mark Zuckerberg's decision. Okay, and so behind this, there is this idea that when we just use the word bias, there would be something which would be related to what is good and what is not the good. And I think this is more subtle than that, because from one side of the Atlantic Ocean and the other side, things which are accepted in one, for instance, think of the death sentence. There is no, of course, a common acceptance of this all over the planet. And who decide that some people are more right than other ones for given thing? And I think that one of the problem of most of the system is that when you tend to have some kind of globalization and uniformization of what is given by the system, is in some sense to impose some form of thinking which are governed by some form of statistical majority but not democratic majority.
I think still I completely agree with everything Patrick said, but we should not discourage people to correct problems. Okay, so for instance, Google advertisement was proved to be biased in favor of to be basically sexist. Okay, so that if you were a man, you were offered a higher job. Payrolls, jobs with more money than if you are a woman. That's just not acceptable for our society. We should not accept this kind of thing. So basically, we have to keep trying to find these kind of biases and try to correct them. And of course, as Patrick said, these are political decisions. We have to tell, it's not legal to do this kind of thing. And when it's not legal, then you can try to correct them. And it's possible technically to correct them. You just have to detect it and have a legal decision.
Perhaps to come back on what you talked about during your speech, Mr. Flandrin, you talked a lot about how actually there's many things we don't understand about AI, and that it's kind of like a black box. How could we democratize AI and make it more available to everyone when there's at least a sort of issue of trust? How can you trust something that you actually don't understand? How could we make maybe AI more understandable to everyone?
I think, again, if you realize that when you are using this system, you are not necessarily getting some truth, it will be good because, well, think of the way you are interacting with humans. In many cases, well, I would say that in some sense, very often we are tempted to ask too much to artificial intelligences. We would like them to be omniscient and know everything and to be always right. But when you think of humans, humans are making errors. Very often when you are discussing with people you do not know that much, depending on how they look like, you will be accepting more or less what they are saying, and this is some form of natural way of using our intelligence, and maybe in some paradoxical way, I would say that an artificial intelligence is passing Turing's test and looks like a human intelligence because it makes errors, as humans do. So if you realize this is not necessarily an issue because you will not take for granted what you are getting from an AI, and I think it's a good thing because when you ask ChatGPT, tell me this or that, okay, you get an answer. You have always the possibility of checking whether it seems to be correct because of other data which are elsewhere with search engines and so on and so forth. So I would say that one way is really not to learn how to discuss with this intelligence in some sense, not take for granted what they are saying and to challenge them, and this will be a first step, I would say.
Yeah, I completely agree with that, but I think we have to also know exactly what you're talking about, because you're saying AI in a bit too vague way. For this generative AI, we don't know, and for machine learning in general, we don't know how to explain the results. But there are many different kinds of AI systems where we know exactly that we prove systems, we know how to prove, we know how to give explanations and so on. So this is just a problem with generative AI, and you have to use generative AI for what it is, which is give you suggestions, give you translation, and maybe accept it or maybe not accept it. I'll just finish with an example. In the medical field, how do you use AI in the medical field? The first idea is to use it for tumors, that's detecting tumors. That's the example that Patrick gave. And that's fantastic. It works very well because there is a doctor afterwards who look at it and agrees or not with the system. Now there is another thing, which is diagnosis. Would doctors accept generative AI for diagnosis? The answer is no. Because if you go to a doctor and you're sick, you don't want the doctor to come up and say, oh, I think you have a flu, or I think you have diabetes. What you want is the doctor to give you precise reasoning, which is because of this symptom and that symptoms, and because you have this examination, then you should do this examination and so on. That's what you want. You don't want somebody to come up with a doctor will not accept an assistant who will just come up with answers. He would accept an assistant that explains everything because of this and this and this. I strongly suspect that these people has this problem. So again, we have to think about, and there are AI systems that do exactly that, okay? So we have to think about what kind of a particular system does and what are the characteristics and use it for that.
Thank you. As you just mentioned in the medical field, how important it is that the doctor give augmentation for what he or she considered what disease you may got. But when you say doctor, the human interaction is also another thing that you cannot ignore. So do you think that AI may eventually replace human interaction for example, services or assistance, as we already see nowadays in websites or phone lines? So how you envision this for specialists like doctors? Are human interactions may be too important or too unique to be replaced by AI?
Yeah, it's difficult to answer this question because in some cases, it's now documented that people develop some form of affective interaction with machines. This was the case, for instance, in Her, the movie which was mentioned before. That's not only a movie. That's that things which come a little bit. Well, I read some papers on this, which come as a compensation from the fact that that's a little bit paradoxical as well, because we live in a world which is mostly digital, and now we have all these social networks which are supposed to be social, but which in some cases tend to isolate people from classical human interaction. And so, well, this is not fully satisfactory, and there can be a compensation by really interacting with something which looks like, some substitute to a human being. So we have to think about that. I think for the medical domain, of course, the human interaction with the doctor, the empathy and things like this are very important, and it's not clear whether this can be done completely by a machine at that time. And I'm not sure, because even if when you discuss with a bot, it can seems to have some form of empathy. It doesn't. You know that it does not. So now we are at the verge of a question which is very, very, very tricky. Are machines able to feel something and so on? But I would just, and I finish with it, come back to what I mentioned before, that precisely when you think of human interaction, there is this dimension of physicalization. The fact that you are in a physical world, and not only a world through a screen or through an audio recording or something like it, but which is in the real world, which has some constraint as well, because you can imagine to do whatever you want in a digital world, in a virtual world, and this is fantastic. But you cannot do the same in the real physical world, because there are laws of nature which impose things to be controlled. And this is why it's very interesting to see the interaction between to see AI in action in the field of robotics, for instance, because it's really something which has to take into account physical constraints of the world we live in, and for the moment we are part of this physical world.
I think this is one of the most essential questions. I think this is really a question that is going to be an obsession for the years to come. You know, what do we want to have these machines do? So the first thing is, what can they do? And for the moment, they know how to imitate feelings, to imitate human beings, emotions, and they know how to detect emotions. So they can interact pretty much in a human way, because they can, imitate and also show emotions. By the way, I should have started by this advertisement. This is exactly the topic of the play that I mentioned, Kiake Gautier, that is showing now. But really, I think it's the most essential question, and I'll show that on one example that for me is really something that is almost an obsession. Okay, what do we do with our old people? This is really something for society. What do we do with our old people? Do we want to leave our old people in homes, their home or some, EHPAD, and have robots taking care of them, AI taking care of them? Maybe the best AI. The AIs, in 50 years, they'll be able to give them the best care. I don't think. I think we would lose as human beings completely our mind if we leave to the machines the full responsibility of the old people. Now, do we want these machines to help us take care of the old people? Yes, of course. And they're already taking care now, for instance, of autistic kids in a way that we cannot do, because they can, be there all the time and be with them all the time. So yes, we want to, as a society, I think, and that's a personal opinion, as a society, we want them to help care for the old. But I think as humans, we want to keep also some of this under our responsibility. We don't want to delegate completely to machines. But again, it's a question of it's a philosophical question. If they do it better than us, maybe we should just let them do it. I just don't personally like the idea, but why not?
Thank you very much for your answers. I think now we can take some questions from the audience. We've got some mic passing around, so you can raise your hand, and Cecile will give you the microphone. So, would anyone have any questions?
Hi, thank you very much. Very interesting and thought-provoking. My name is Colin Kramer. I'm at the ESCP and I'm part of the Career Center. And my biggest question is, how do we equip the generation that's learning today, and our generation, but really the young people today, to be resilient, able to embrace the technology, able to use it in a proper way, and let's say survive in this new world?
I think, of course, and it's not because we are here in an academic institution that I'll say that's a very critical question. So I'll give you an answer that's probably not going to be very popular. First of all, you should teach them computer science. I think the world is digital. The world is basically influenced by this technology, and they have to learn computer science. They have to learn how to program. And that, I told that to lawyers. I'm telling that to lawyers. I'm telling that to business people. I'm telling that to historians. I think you have to understand the basic technology. I think programming and computers is exactly as mathematics is something that everybody should understand. And that they should understand that because this is the machine is called a computer is a general purpose machine. It's a machine for everybody. And AI is also the same thing. AI is a general purpose tool, and everybody should learn how to use it. Now, if you ask me, how do you learn these kind of things? I would say by practicing. I mean, these are not, computer science is not something that you learn in a theoretical manner. Of course, you have some theory and you should learn the basics, but basically you learn it by practicing, by experimenting. And AI is the same thing. The only way I know, of course, you need to have the basic theory about AI, understand what it is, but the only way I know, especially for machine learning, is to practice it. Get your hands on real data, play with real data, do some real statistics, do some real machine learning. Okay, play with Midjourney, do something. Okay, and that I think is the essential part that should be part of the curriculum.
No, I completely agree. But I think that the question is also difficult because things are changing very quickly. And so that's when Serge talks about practicing and learning this way, it's something which has to be rethought about every day in some sense, because what we now can do with these technologies and with this system, we couldn't even imagine that, I would say, 10 years ago. That's really, and so we can also think the other way by saying that what we are doing now will most likely, in terms of just the technicalities and the actual system, will most likely be obsolete within 10 years. So what's important is, of course, to practice with the current system which are available, but also to always have an idea of where it comes from and what are the general ideas, not the details, which are really for computer scientists and the developers and so on, but to understand a little bit what is going on. But this is something very difficult, and that's not only for AI, that's for everything which is digital, but that's also something which is, well, when we were younger, for instance, we could repair our car when we had a problem. I don't think now, first, not only we can't, but we are not allowed to. And the same is true. Even if we have ideas of what are we must confess that really understanding what is going on in our smartphone is quite difficult. And we would not be able to, to change anything and to repair a smartphone.
I don't. And to go in your direction, I'm saying, you know, you have to learn how to learn computer science and programming. But just take this very simple thing about programming. You learn that in a class in like 20 hours, 30 hours. It's not so big deal. But it's completely changing today because there are tools like Copilot that help you program. So personally, I don't know how to teach. I mean, I'm a computer scientist. I've taught computer science. I've taught programming. I would not know how to teach it today because we have to reinvent it completely. So again, this is to put to put your problem at the right thing. It's difficult.
Yeah, I think that really two facets with respect to education. That's to be educated to AI and to educate with AI. And the two are going a little bit together because things are changing quite fast.
Yeah, thank you for that. Because you know, when I repivoted my career, I went and spent 10 months at École 42, and at an older age learned how to code. But I come from an engineering background, and so I could do that. I learned how to code with compilation cards in South Africa a long time ago. And you talk about going to lawyers, and I don't want to take this conversation, but I know a lot of people in France and French schools who couldn't do maths and physics, so they were sort of sidelined to out of ES and whatever, and they had to take other lines or they went into other areas. So I know this challenge. How can you, with your expertise, help us as educators find a way to help those that aren't maths logically inclined, but have more the linguistic approach? You know, is there some connection there?
I'm sorry, because the solution lies way before. I think the problem comes from when kids are 10 to 12. And at that time, in France in particular, and there are some very bad results recently in the press, in Le Monde, for instance, in France, the students start getting away from science. And we have this completely stupid historical bias in France where we separate the world between science and not science, and you know, hard science and the rest. And that's completely impossible in today's world. In today's world, if you are doing humanities, you do humanities with the proper tools, and the proper tools mean databases, the proper tools means AI, means a lot of things that are very scientific. So we have to basically stop splitting the world between the two, or the three if you want business in the third part. But really, this is it's really something that's not acceptable. Unfortunately, the problem doesn't come at your level. The problem comes much, much, much before. And when the students get to you, it's somewhat too late for them. And that's really a problem in France.
And the converse is true, because it's not because you are doing science that you should not be concerned with the humanity part, which is also intimately linked to this. So the position is not to say just I'm doing science and then I don't care about what is the impact in society and so on and so forth. But I completely agree. And if we come back to the former question about gender bias, for instance, clearly we have also this problem, which is, I would say, twice the problem when which is concerned with computer science, but globally with the science and the way we have. We don't have a balance between the genders in science, and especially in computer science, comes from the very early days of the elementary schools. And we worked on that at the academy. We produced a report, and it comes also. That's a way of thinking about learning by examples, because it's the question of the role models and the way the pupils are faced with instructors, which are mostly female instructors at the very elementary level, which are not trained to science as much. And when it comes to science, and Claude Jopard, who is here, could comment on that, because he's heavily involved in this question of education at the academy, when things seems to start to be serious, then you have male instructors. And this is one way of projecting the idea of that science should be a male issue rather than a female issue, which starts when the kids are maybe 6, 7, 8, 9, something like this. And this is an important issue. And this is some form of bias that can be corrected, that should be corrected. And
yeah, we are very bad in France. Results are actually terrible.
Any other question from the audience? Maybe just to come back on education, I thought maybe could one of the solutions to kind of closing the gender gap in education could be learning with AI about coding. So you talked about how you can learn to code with Copilot, and there's also, I think it's Black Box, like the AI that helps you create code. So could this actually help close the gender gap, as it's something that's kind of available to anyone if you just have a computer?
I mean, this is actually it's a very interesting and it's a question. You know, I'm working with foundations like La Main à la Pâte or Blaise Pascal, where we really have problems. You know, we really have problems with gender, and we also have problems with social backgrounds. You know, in France, if you have from the wrong social backgrounds, your chances of success in education are much, much lower than if you are from the good background. And these are two problems. And of course, now comes a tool, which is AI. And of course, we ask the question, can this tool be used to solve our problems? I would love to tell you yes, I just don't know yet.
yeah, and I also, maybe if I may, we have also the same kind of issue. For instance, we mentioned that on the one hand, the huge development of AI creates some issues in terms of energy consumption, environmental issues. And at the same time, AI solutions are there for optimizing system and helping to fight against the problem we have with the climate and things like this. So we always have the two facets, and the question is to have a good balance so that hopefully we can have more profit of good use, for instance, in terms of decarbonization with AI, not at the expense of using tools which themselves are extremely expensive in terms of consumption of energy.
And in terms of you know, increasing discrimination, I mean, you know, I cannot tell you. Maybe only boys will be fluent in AI and will take advantage, and the gender gap will increase. It's still, you know, it's still open.
Can I ask a question? So, what do you guys think about creating an AI for people with learning difficulties? Because that's also part of discrimination, no? And for me personally, because I grew up in a Anglo-Saxophone education system, studying in Swiss and in France, I was actually at ONS for an exchange. They were quite supportive, but at the same time, they didn't know how to help certain people. And to me, that was kind of shocking of like, oh, they don't understand how it works compared to like in UK or in the US. Do you think there could be a special AI that could be created for people with learning difficulties, as you said, and that could help maybe certain people who's not as strong in science or math in high school or before prepa, and then they end up getting other opportunities that others couldn't get from years back?
Extremely good questions. I think there are fantastic opportunities. I know, for instance, about education of autistic kids with you know, using AI. I know that people are working on for kids with different kinds of inabilities. They are huge potential, because basically what you can do is you can adapt to the learning speed of the kid. You can also adapt to his needs, his or her needs. So huge potential, but you know, we have to wait to see.
And I think we can make a parallel, for instance, in medicine, where the the development of personalized medicine, which is something which really can meet the needs of a specific person, and this is really helped by systems which come from learning, which could be AI based and so on. And we can think of the same thing for some form of personalized teaching and education, precisely not to that's always a question of to take care of the specificity, and well, that's this can be envisioned. I don't know exactly of who is doing this kind of thing.
For the moment, what I know is I don't know of in France.
No.
I don't know of existing solutions. So I know, for instance, that they're all interested. There are some ed tech working on it, so startup working on it. I don't know of solutions.
Another question is, I'm actually going into a tech company on ESG department under generative AI, but I'll be helping more with like a retail sector and more procurement and sales. And in a way, I think it's a very dangerous ability to manipulate like the possibility of how you can push people towards retail. But at the same time, I think if it's regulated right, it could be used in a very nice way. What kind of obstacle do you think the company, or I guess a country, needs to put into the system in a specific country so they don't over maximize the use in a bad way? Does that make sense?
Yes, it makes sense, and I think in particular there is lots of money involved. Yeah. So companies are investing, and again, coming back to the question of Patrick, at this point we should balance the advantages for society versus the environmental cost for the society. So that's one dimension, and the other dimension is, of course, not overdoing it by using, dark patterns or things like that. So in Europe, we are a little bit protected by the laws like DMA, but it's a touchy issue. I think companies should show responsibility, but on the other hand, you cannot ask a company to refrain from making money, because the goal of a company is to make money. So I think regulation should maybe be a bit stronger, so that to prevent abuses.
All right, thank you.
Any other questions?
I may pose a question. Okay, I have a question. Like you mentioned the regulation, so I'm curious. Like, do we have some really strong regulations, code of conduct, or even law, no matter soft law, hard law, like this, to regulate the use of generative AI? Especially after you mentioned that we could be biased because of the designers. So if there's any opinions or truths that I could know from it, it'd be great.
Okay, that's what is difficult with the regulation, as we mentioned before, is that you have different time scales. Because on the one hand, you have technology which advances quite fast, and very often the time needed for thinking fairly about regulation is not on the same time scale, which means that when you end up with some kind of solution to a problem, most likely this problem is not the most important one at that time, because a new problem has arrived. Nevertheless, there are, for instance, at the European level, there are some first regulation which are proposed with the AI Act, and especially with the something which should be done each time we are using some form of learning system, which concerns, for instance, the nature of the corpus, how it is, what is the corpus, where it comes from, and does the company has any form of consent of getting the data? Of course, in some sense, everybody is given his data because the system we are using are free in some sense, but nevertheless, it's not because we are using freely this system that you could consider that this data can be used without you to be informed about this use. These are things which are important, and also to know something about the nature of this corpus, for instance, for this issue of the fairness of the data, which will be very important in terms of the output of the algorithm. But otherwise, the problem after that is that this is some problem which is not only at the scale of a continent, but which is a worldwide problem, and it's very difficult to consider something which would be a worldwide regulation, and also not only that, but also to control this, because it's okay. You can say you should not do that, otherwise you will pay some huge amount of money. Okay, but people can say, okay, I will pay some huge amount of money. So, and what you will do in Europe would not necessarily be done in China or in the US, and then you have all these issues of competitivity and competition and so on. And that's very, very complicated problem, I think.
Yeah, it's a very complicated problem, and for the moment there are discussions at the world level, but basically as always in the world level, it's impossible to get to a regulation. So for the moment, the main there are some regulations in UK also, but the main regulation is in Europe, the AI Act, and some of the things that Patrick mentioned, which is talking about the data that you use. There is also something about the effect. But again, you should re-prefix that, but it's very difficult to make a regulation for a technology that's progressing so fast. So, but still, so what is, oversimplifying what is in the regulation in Europe? It's to say you have to tell us when you start doing an AI system, and there is already a definition of what an AI system is. When you start doing an AI system, you have to think about what you're going to do with it, and depending on the level of risk, you have different levels of obligations. So at the highest risk is you just don't do it. This is forbidden with AI systems. Almost impossible to get there. At the lowest thing is if you're doing some kind of just recommendation system for restaurant, for instance, don't bother. You can just do it. And in the middle, then the higher you go, the higher the obligations. The main difficulty with AI is that the same technology can be used for so different things that it's going to be very difficult to enforce. So basically, you can develop a technology. When you get to an application, you're going to say, well, my application is very limited, but it's very difficult to prevent someone to take the same technology outside Europe and to do something totally different. So again, it's a first step. It's not very big. It's not very important. But I think, in a way, you have to be slow with regulation, because regulation is something that has to mature in a way.
Okay, thank you.
Do we have any other question from the audience, or is this well, I mean, if I may have just one last question, because we haven't really talked about politics, but in the recent elections, we saw quite a big rise of deepfakes. Would you say that with generative AIs, and in particular generative AIs that produce images or videos or audios, we might have a reconsideration of kind of the famous sentence, I only believe what I see, or only believe what I hear, where we might get into a world where we can't believe what we see or what we hear unless we actually see it with our own eyes, like right in front of us. What would you think?
The day I'm very optimistic, I say that's great, because people will start believing bullshit, because they'll know that's probably fake. Now, if you want my more serious opinion, I think at some point we should start authentication, use authentication, which is I don't want to know about a fact or a picture. I want to know who has produced this fact and who has done it, because basically, you know, the world is, as you said, is full of deep fake, and is going to be more and more full of fake stories and so on. So really, people have to be taught and they have to learn that they should not trust anything, so that you trust a source that's serious. And for that, I think at some point you need signature. And I think in particular, you need signature for everything that has been computer produced. And that's, you know, that's actually something that that Patrick insisted about, which is how do you learn from an environment when more and more has been produced automatically? We absolutely have no idea of what's going to happen. We are completely in the wild, that's a situation that we will discover. And I think the best would be not to go to that situation and to start, you know, signing everything that's generated automatically, so that we know. And for instance, we don't train our future generative AI on automatically generated documents or pictures.
Well, many thanks for your answers. I think we can conclude this conference, and well, yeah, many thanks for all your insightful.
Thank you for the invitation.